Welcome back to another episode of Study Time on the Active Recall YouTube channel. This is where things start to get a little bit more exciting with regards to subnetting. We're going to be analyzing networks given an IP address and a subnet mask. And we're going to be mixing in some class rules to give us some information about the structure of the network that we're going to be analyzing. This is of course assuming that one subnet mask is being used across the whole network. I drew up a lot of study notes, and this video is probably going to be short because it's pretty straightforward. We're just going to be combining all of the concepts that we've been learning over the past 2 to 3 videos to give us some pertinent information about the networks that we're going to be analyzing. Let's jump right into it. We're going to be analyzing networks given an IP address and a subnet mask. This is pretty straightforward stuff when it comes to subnetting. This isn't where things get too complicated, not if you grasp the concepts that we've been studying over the past 2 to 3 videos and hammering those practice questions such as converting subnet mask between binary and DDN and between DDN to prefix, and that's where all of this comes together nicely to help us analyze the networks with information that we're given. And you're going to see right here, our goal is to be able to analyze a network given the IP address and the subnet mask. We should be able to answer some questions about the network such as the class, the host bits, the number of hosts in each subnet, and the amount of subnets that's in that network, right? Now that we know how to break down IP addresses using classless and classful addressing rules, we can analyze a network and articulate its structure when we're given IP addresses and subnet masks. Pretty straightforward. And these study notes, I drew them up so that, it's pretty straightforward. We stay on cue, and I'm going to make them available at some point just to review classful and classless rules, right? Classful rules means that we think of an IP address as having 3 parts: the network part, the subnet part, and the host part, right? It's outlined by the mask or dictated by the mask and class A, B, and C rules, right? And we're going to see what that entails as we move further into the study session. So classless rules mean we regard the IP address as having 2 parts, and we disregard classful rules, right? So we think of it as having just the network part and the host part. We don't think about the subnet part, and that's pretty straightforward with that. So now, since we're armed with the knowledge of how to break down an IP address using both classful and classless rules, we can use this information to bring together our analysis of the network, right? And when we get this information, we just have to plug it into 2 formulas. These formulas are going to tell us something about the network: how many hosts each subnet has and how many subnets are in the network, right? Or how many subnets can be made available, right? If we want to figure out how many hosts are in the subnet given H, or when we find H, this is the formula that we're going to be using. It's going to be 2 to the H minus 2, where H indicates the number of host bits, right? When it comes to shifting it all over the place. Now, when it comes to subnets in the network, we're going to have 2 to the S, where S indicates the amount of subnet bits in the IP address. See, this is where the classful rules come into play, because we're going to have to split this IP address up into 3 parts and use the information that we get from that to figure out how many subnets are in the network, and of course how many hosts are in each network, right? We're back to our nice little drawing, right? And this is the IP address, right? So say this is the structure of the IP address. And this is of course going to be using classful rules, because we see that the IP address is split up into 3 parts, right? We have our network part, we have our subnet part, and we have our host part, right? All of these are expressed in bits, right? I'm all marking this up. It's all expressed in bits, right? And of course, we know that the IP address consists of 32 bits, right? And that's where we have 32 bits. Now we know that each class of IP address corresponds to a certain amount of network bits, right? For example, we know that it's 8 bits in the network part, right? I don't even want to say network part. We know that class A means 8 bits for the network, right? Because I don't want to confuse network part with network bits, because network part includes the subnet part, and that is for classless. Like, that's if we were talking about a classless IP address, right? So the network part would consist of the network bits and the subnet bits, right? But here we're making a distinction because we know that A has n equal 8 bits for the network, right? So B has n equal 16 bits for the network, and C is n equal 24 bits for the network, right? Boom, boom. So what are some examples of class A, B, and C IP address, right? So we have an example here, right? We'll have, I don't know, 10.1.1.2, right? We know that it's class A, right? Because this falls between 1 and 126, right? And we know that this is a example of, I don't know, random 172.16.2.8. That's class B. And we know class C already, right? 192.168. We see this one a lot when we're setting up our Netgear or Linksys or whatever wireless access point / router / switch. We see this as the default IP address that we need to know in order to log into the web server and start configuring our settings on the router, right? So we're very familiar with the class C. I like to use class A because it's different. I don't know. And I usually use this with a /30 for my WAN links, right? We've seen that before in the video where I'm connecting 3 Cisco routers together. So let's move on because we're getting off topic. I'm getting so excited about this. Right, now that we have all of the information we need at our disposal, we can calculate everything we need to know, right? This is where the various conversions of subnet masks are going to come into play. You're gonna watch how this play out, right? Now, as the book outlines, there's a 6-step process, right? And I gotta pull up the book real quick so that I can get some of the practice problems up for us. Let me put this over here. No, but yeah, let me put this over here. I need a bigger desk. So as the book outlines, and I'm using this book, about to show you guys real quick. Let me show you again what book I'm using. This is the book I'm using. I'm using the official cert guide, right? CCNA 200-301. Wendell Odom. This guy's the GOAT. He's really good at writing, and he's really good at explaining these concepts in such a way that I can understand, so that you can understand, so that we can all understand, right? So let's get back to it. Boom. So I like the way the book breaks it down. I don't know if it's broken down like this in other books, but we have a 6-step process, right? We're going to convert the subnet mask to prefix format if it isn't already in prefix format. And you're going to see why in a second, because we have a few other formulas that we have to know in order to get the information that we want. The next step is using Classful Rules, determine n, right? Remember, this is where we was doing all of this magic, right? Boom. The third step, calculate the subnet bits, which is the prefix minus n, right? And we're going to calculate h, which is 32 minus p. H is host bits. And that makes sense because when we have the prefix, which is the, let's say it's the subnet mask. We know it's the subnet mask, right? 255.255.255.0. We know that this whole thing, right? Say we have an IP address. Let's just say we have an IP address somewhere. I don't know. Call that IP address. We know it's 32. No, it's 32 bits, right? And we know that since this right here consists of 24 bits, is going to be 32 minus 24, which is equal to 8. It's going to be 8 bits, right? So it's just simple subtraction, and we find out what the host bits are, and you'll see how it all plays out later on, right? And then now, after that, we have a lot of the information that we need. We're going to calculate host per subnet using 2 to the h minus 2, right? I should have wrote this 2 to the h, should have wrote it out like that so it doesn't cause any confusion. This caret symbol just simply means to the whatever power, right? So 2 to the s, and boom, right? That's step 6. Calculate the number of subnets using 2 to the s. S is subnet bits, and we know h right here is going to be host bits, right? So that is all we need to know. That's all of the information we need to know. We have to, all of everything that we've been studying for the past 2 to 3 videos all boils down to this so far, right? And this helps you to analyze the network given the IP address and the subnet mask, right? So if you're given, let's do a practice problem real quick, 8.1.4.5 and 255.255.254.0, right? And the first thing we need to do is to convert the subnet mask from dotted decimal notation to the prefix format. In order to convert it from dotted decimal, we can convert it to binary. We can convert to, so that we can convert it to prefix, right? So here we go. 255 is equal to 8 ones, right? We know that 8 bits are turned on. And then what's this number? This is the interesting octet. Interesting octet, and we're going to get more into that fancy terminology in our next video. We know that 254 translates to 7 ones. Right? So that is the binary form, right? And given this right here, we know what that is if we were to just look at our chart from the last video, right? We have to memorize those 9 values, or we don't have to memorize them, or what have you. I usually just count on my fingers sometime, but you can memorize those values and just straight up just plug it in, right? Just replace what the value is, right? So we know that this binary converts to which is going to give us 23. So we know P is equal to 23. Now we need to figure out what the class of the IP address is so that we can figure out what N is, right? So we know that that 8 is going to tell us what class the IP address is, and that 8 falls between 1 and 126. So we know that it's a class A, which determines that N is equal to 8, right? So N is equal to 8 because it is a class A IP address, right? So now our next move is, what is S? S is going to be equal to P minus N, right? And that makes sense because if we were to take our subnet mask, right, a subnet mask, we know that that subnet mask is going to break that IP address down into a few parts, right, depending if we're using class rules or not, and which we're using class rules right here, as you can tell, because we have N in the equation. So it's going to break that IP address up into 3 parts, right? So we apply the subnet mask, the prefix, And when it hits that network part, it breaks it up into two parts, right? The network bits and the subnet bits. So now we have 23 minus 8, and that's going to give us 15 subnet bits, right? Give us 15 subnet bits, which means that that's equal to S, right? So now the next thing we're going to do is figure out H, which are the host bits. 32 minus P, 32 minus 23, and that is going to give us 9. Now, this also makes sense because when we are not using class rules, meaning we are looking at the IP address as if it's just two parts, we could take that subnet mask, apply it to that 32-bit IP address. IP addresses are all 32 bits, right? And then we get a leftover amount for the host bits, which is going to be 9, right? So we know that H is equal to 9, S is equal to 5, P is equal to 23, and N is equal to 8. So now we have pretty much everything that we need to determine how many hosts per subnet and how many subnets exist in this network, right? Or how many subnets can be made out of this network. I think I'm using the wrong terminology there. Oops. So we have 2 to the H minus 2, right? This is going to give us our hosts per subnet, right? We're going to have 2 to the H, which is going to be 2 to the 9 minus 2. And 2 to the 9 is equal to 512, right? Minus 2, 510. Now, this 2 right here, and I forgot to mention this before, right? This 2, what is that? Well, we're reserving 2 IP addresses in each subnet. This is just basically how it goes, right? We reserve 2 IP addresses per subnet to define the subnet ID and the broadcast address, right? You can't use these for hosts. So this is subnet ID and broadcast address. So we have to automatically take those 2 IP addresses out. And everything in between are the valid hosts, right? And we're going to learn more of that in the next video. So we have 510 hosts, right? Now we have 2 to the S, which is going to be 2 to the 15, which is, I memorized this number. It's going to be 3, 2, 7, 6, 8. That's how many subnets we can have. And that makes sense because it's a class A IP address. Class A IP addresses are huge. They're big networks, right? So, and that's by design. You know, I'm not going to go into the history lesson behind it, but that's by design, right? The Class A IP addresses or the Class A networks tend to be these big networks with a ton of hosts, and yeah, that's just the way it is. But that's one practice problem, right? I mean, if you guys want to do another one, we could run through another one. Let's run through another one real quick. So we have another IP address here and subnet mask 130.4, and I'm taking this right out of the textbook, .102.1 with the easy mask, right? This is an easy subnet mask. So what's the first thing we do? That's right. We're going to convert this to the prefix, right? We already know off rip that once we see 255 3 times in a row, that's going to be /24, right? Because we know it's going to be 1, 1, 1, 1. We know it's going to be 24 ones in a row. It's 24 ones in a row. Boom. That's the prefix, right? Now, what's the next thing we have to figure out? the next thing we have to figure out is what class IP address this is, right? And we know that this is going to be a class B address. It's a class B because this octet falls between 128 and 191, right? That's class B. So we know that N is equal to 16, right? So now we got the prefix and we have the N, right? And determine the prefix and the N. Now the next step is, what are the subnet bits, right? S is going to be equal to P minus N, which is going to be 24, right? We're applying that subnet mask to this IP address where we're using class rules, right? Minus 16 equals 8, right? So that's 8 subnet bits. Now we're moving on to the host bits. 32 minus P. This is almost as if we're not using any class rules at all. We're just taking the mask, applying it to the IP address, and we're getting our value, right? 32 minus P, which is 24, is equal to 8. Now we're going to use our formulas to figure out how many hosts per subnet, and we're going to figure out how many subnets are possible, right? So hosts per subnet is equal to 2 to the h minus 2, which is equal to 2 to the 8 minus 2, which is going to be equal to, we remember what these are, right? We automatically taking that out because it's the subnet ID and the broadcast, right? So 2 to the 8 is 256, right? Minus 2, 254. And now we have 2 to the S, right? Pretty straightforward. 2 to the S, which is equal to 2 to the 8, which is equal to 256 subnets. So I was all over the place. Hopefully you guys saw it. I was all over the place, but these are our calculations, right? We know that the prefix, is equal to 24. Then we knew that N is equal to 16, so network bits. Then we knew that the host bits is equal to 8, right? And we knew that S, what was S? S is equal to 8. And we knew that the hosts per subnet was equal to how many? How many did you say? 254? And we know that the number of subnets was equal to 256. So that was pretty much it, right? It's pretty straightforward. We see how, combining the concepts of classless and classful helped us to analyze an existing network using an IP address and its subnet mask, right? We was able to think of an IP address in two ways, as being or consisting of 3 parts or consisting of 2 parts, depending on the rules we use and the rules we don't use, right? And we were able to drill down into the subnetting stuff, right? How many hosts per subnet, and how many subnets can possibly or exist in that network using the IP address and the subnet mask, right? So we see that we're getting a little bit more, we're getting a little more detailed, and we're diving more into these concepts of subnetting. And that's pretty much that. We're gonna move on to our next video, which is going to be, we're gonna be calculating subnet ID, broadcast addresses, the first and last host, What else we're going to be doing? We're going to be using and pulling all these concepts together that we learned over these past 2 to 3 videos to start to get the full picture of subnetting. And again, this is when using one subnet mask throughout the whole network. So if you want to see some of the previous videos where we discuss some of the basics and the fundamentals of subnetting and IPv4 anatomy, click right here, and I'll talk to you guys next time.